Hello everyone. We already have an intuition for this theorem at Math Decoded. The theorem says equal chords of a circle subtend equal angles at the center. So if chords are equal in a circle, for example you take two equal chords in a circle, then the angles they make at the center are equal. We saw this intuitively by drawing different chords of different lengths, and compared the angles so made and arrived at this. But here we are going to prove it formally, a formal proof for this theorem. Equal chords subtend equal angles at the center. So consider this circle, and let's say we have two chords which are equal in length. So this is one chord, let me call it AB, and we have another chord CD, and it's given AB is equal to CD. The length of AB is equal to the length of CD, and this is the center of the circle O. Now we'll have to prove that they make equal angles at the center. So the chords subtend equal angles at the center. So what do we have to prove? So in order to prove, we'll have to see how the angles are made. So let us connect the ends of the chord to the center. So OA and OB. This forms a complete triangle AOB, and similarly connect OC, join OC and OD. So we have a second triangle here COD. We'll have to prove that the angles subtended at the center by these two chords are equal. That is, we'll have to prove angle AOB is equal to angle COD. So let's begin. Already we see that OA and OB, and of course even OC and OD, are radii of the same circle. So all of them are equal in length. So let us use this property. OA is equal to OA of the first triangle AOB. So we have two triangles. Let me write down the two triangles. One in green, triangle AOB, and we have triangle COD, right? So we have OA, length of OA is equal to the length of OC. Both are radii. The reason you give is they are radii of the same circle. They are equal. And similarly, OB will be equal to OD. Once again, radius of the same circle. And we have been given already that the chord lengths are equal. AB is equal to CD. So the third side of these two triangles are also equal. That is, we have three corresponding sides of the two triangles equal. So we have seen in the congruency of triangles. If you want to recollect, we'll post the description here, the link here. We'll have seen that if the corresponding sides are equal, then the triangles are congruent. Congruency means that the triangles are one and the same. The triangle AOB and triangle COD are exactly the same. If they are placed on one another, they just coincide. So what does that mean? The angles are equal. The angles which we require, which we want to show are equal. Angle AOB is equal to angle COD will be equal automatically. So since the three sides are equal, we can say that by SSS, or side congruency, triangle AOB is congruent to triangle COD, which implies that angle AOB is equal to angle COD. This is by corresponding parts of congruent triangles. CPCT just means corresponding parts of congruent. If two triangles are congruent, all the components are equal to one another, the sides and the three angles. So we have proved what we wanted to establish, and in the process we have established this theorem: equal chords of a circle subtend equal angles at the center. Now what is the converse of this theorem? How can we write the converse? If we are given that the angles are equal, we'll have to prove that the chord length is equal. So let me read out the theorem to you first. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Now using the same congruency property of both the triangles, we can prove this theorem also. Let us take two chords. This time we do not know whether they are equal, or which one is bigger or which one is smaller. All we know is the angles which they subtend at the center. That is, if I connect the endpoints of the chord to the center, the angles so subtended are equal to one another. Right, so what we know here is angle AOB is equal to angle COD. So this is given to us. And what do you have to prove? That the chord lengths are equal. The length of AB is equal to the length of CD. This is what we'll have to prove. So how do we go about it? In the same way, we have two sides equal to one another, being the radii of the circle, and the angle included in between the sides are also equal. So we have OA is equal to OC, OB is equal to OD, and we also have, which is given to us, these two angles are equal, and hence because of all this, since three parameters of these two triangles are equal, the triangles are congruent, or formally we'll have to mention that by SAS congruency, which means side angle side congruency. Both the triangles are congruent to one another. Triangle AOB is congruent to triangle COD, which tells us that these two lines, the chords, are equal in length. AB is equal to CD. So we started off with the angle subtended being equal and proved that the chord lengths are equal. This is the converse of the previous theorem. I hope you followed. Thank you.